Hello, everyone. This is Julie Luby, the Assistant Superintendent of Schools from New Fairfield. I am very pleased to be talking with you this evening and joined by two super people. I have with me Dr. David Gropper, a local pediatrician whom many of you may know, and our wonderful head nurse, Nurse Cipriani, who's also our COVID liaison. Our purpose is that we'd like to try to get some good, clear, and accurate information to you about vaccines. We know that there's a lot of confusing and conflicting information, and we hope that by offering you some information that came from someone local whom you knew and trusted, it would help you with any decision making that you may be faced with. So, Dr. Gropper, do you want to say hello?
Sure. Hello, everybody. As mentioned, my name's David Gropper. I'm a pediatrician and I work at Pediatric Associates of Western Connecticut with 10 other providers. Our practice has been in this area for the last 60 years or so. I've been in practice for 32 years and I'm also a parent of a 29-year-old. I just want to let you know that I have no disclosures, that I'm not being influenced by any insurance company, pharmaceutical company, media company, and to the best of my knowledge, I'm not getting paid off to talk to you. So with that note, I think we can move forward to Lori.
Okay. Hi, Dr. Gropper. Thank you so much for joining us. We really appreciate you taking the time to do this with us.
Sure.
Let's just start out by maybe just having you tell us a little bit about the COVID-19 virus itself.
Sure. Well, first, let me explain where the name comes from. COVID-19 is a new or novel virus that came from China, somewhere around Wuhan. It's not clear exactly where it came from, and it's fairly irrelevant to us at this point. Due to modern transportation, the virus spread across the entire Earth very quickly, and that's why it's a worldwide pandemic. The name comes from CO meaning corona, VI for virus, and D for disease. And since coronavirus disease was first identified in 2019, it's called COVID-19. So that's where it does make some sense. It is in the same family as the SARS-CoV-2 viruses or this severe acute respiratory syndrome viruses. There was an outbreak that probably none of us remember, but it was very severe in other parts of the world in about 2003. But this, of course, has been much more severe and affected many more people in many more areas than that outbreak. So that's why we're talking about this.
Okay, great. Thank you.
You're welcome.
Can we talk a little bit about the three types of vaccines that are out there right now for COVID?
Sure. Well, there's three different brands. One is made by Pfizer, one is made by Moderna, and the other is made by Johnson & Johnson. The first two, meaning Pfizer and Moderna, are mRNA vaccines. The third one is an adenovirus vector vaccine. Now, since the only thing that is currently available for the students between age 12 and 15 is the Pfizer vaccine, I'm essentially just going to stick to that vaccine because nothing else has been approved so far. I know that there are studies ongoing for the other vaccines, and I also know that there are studies to look at the effectiveness of all of these vaccines in the younger age group, which usually is cohorted in the 5 to 11-year-old age group. When those studies will be done and when the vaccine may be available is unclear. If I had to give you my best guess, and it's honestly a guess, I would say early winter. And we're assuming that I haven't heard any bad news, but I also haven't seen the studies. So we'll see what happens.
Okay. And just to clarify, can you give us some information discussing the differences of DNA versus RNA when in relation to the types of vaccines that these are, given that they're the mRNA vaccines, particularly Pfizer?
Sure. So let me start with a little bit of basic science. I think we all know that we're made from cells, okay? As I mentioned earlier, I've spent considerable time creating this masterpiece, okay? You may all laugh, but it took a lot of time for me to figure out how to do this. I am not proficient with computers, just ask my 29-year-old, okay? So we have cells. These cells have a center, which is the nucleus, a cytoplasm, which is basically the C around the nucleus, and a cell membrane which covers the whole cell. Now, things don't just go in and out of cells or anywhere else without either special keys to get in, and I'm using it as an analogy, or some other mechanism. So you don't randomly transfer information from here to out here or from here to out here without there being a purpose for it or a reason for it. The genetic code that there has been some concern by some people that the mRNA viruses will affect your genetic code. I'm going to go through this in just a minute, but your genetic code is in the nucleus, which is in the center. That's where DNA is. That has nothing to do with it. There's no direct connection between that and messenger RNA, which is out here. This does not go into the messenger RNA does not go into the nucleus. So there's no way for the vaccine to create a problem with your nucleus or your genetic material. The other thing is that the vaccines are a small portion, which you'll see in a minute, of the virus. So you're not putting the virus into the person, you're putting one little component of it, which I'll show you on the next slide. And so RNA cannot get into the nucleus, and it's impossible for the vaccine to affect the nucleus because there's no connection there. Probably I'll just move on to the next area, which is how does this vaccine work? Okay, the first thing to understand, and I will confess that I didn't know about mRNA technology myself because honestly, there's too much data and I don't follow basic sciences, but this technology is not new. I mean, it's 10, 20 years old. It's been used for things. It's mainly been used in cancer treatments, and it's been very effective. Since we needed to create a vaccine very quickly, a lot of people who are a lot smarter than I am decided that this would be a reasonable way of doing it. What they're doing, they're essentially taking this, I stole off the internet, by the way. That's why it looks pretty. They're taking COVID-19, here's a lovely looking COVID-19, and taking the spike protein, hopefully I'm pointing at the right thing. Yep, these little red dudes, okay? And they are taking those little red dudes, the spike proteins, they're covering them with a bunch of fat, okay? And that fat allows the red dudes or spike proteins to get into my old friend. This can't just, if you get infected, it has all kinds of ways of getting in there. But if you have a vaccine, you need to take what you're trying to get immunity to and allow it to go through here. And fat allows it to go through. That's why it's complicated. It's not, you don't put some corn oil and dump it in a vaccine. You have to have specific, very specific fats. So it goes in, the vaccine goes into the cells, it replicates out here. I don't know how it gets out, but it pushes its way out. And then you have a whole lot of these dudes, spike proteins, floating around in your blood. When your body sees something that doesn't belong there, it has an immune response. The immune response is to create antibodies, okay? There's a whole different set of your immune system called your cellular immunity that I could spend forever trying to explain, and we'd all be confused. Just accept the fact that you put this stuff in your blood, your body has an immune response. When you get immunity to it, you can protect yourself. So if your body sees a COVID, it says, oh no, this is a bad thing. I'm going to get rid of it. I mean, that's how we work with everything. When we're born, we basically have our mom's immunity. After a couple of months, we have no immunity. And then I don't have to tell you, anyone who's had children, that little kids get sick continuously because they're not immune to anything. You don't get the same cold 75 times. There are 200 cold viruses in any one community. There may be 60 that are common. So you get, rhinovirus 1, rhinovirus 2, 3. You have to get immune to it. That's what we're doing when we're creating immunity with the COVID vaccine. And as I said, just to make the point, there's no way to get the virus from the COVID vaccine because you're only taking this. This doesn't do anything. I mean, it's part of the virus, but it's like saying I just pulled the handle off my car and now I have a car and I'm going to drive around. It's impossible. Okay, it's a little piece of it. It doesn't replicate. It just is something that we can have an immune response to. It's the same way that most modern vaccines are made, only in that it was new technology used for vaccines, not new technology in general, and it's really, really effective. It's in fact, in my opinion, for what it's worth here, I think it's probably going to end up being used for a flu vaccine, which is incredibly difficult to make in eggs. And that's why it takes so long. They have to decide in March when to make the vaccine or what kind to make so that you can get it in August. And I think that this is going to change that field, but you know, that's way out of my area. So
Okay,
that's
perfect.
some of the basic science that hopefully clarifies it a little bit.
Absolutely, that helped a lot. So the next question would be then, why does it have emergency approval versus the final approval from the
Okay.
FDA?
That's a fairly simple thing to answer. Okay. The way the government normally works is in sequence. Okay. You do step 1, then step 2, then step 3, then step 4. And if you've ever dealt with the government, you'll understand you don't vary from that. You just go 1, 2, you know, it's a sequence. What happened with this was that 1 through 50 all happened at the same time. It's as if you were building a house. If you were building a house and you had the foundation down and you started to put up the framing, and then you waited and got the plumber, and then you waited and you got the electrician, and then you waited and you got the, you know, it's as if everybody came, you know, once you have the basic structure, everybody came and was working at the same time. That's how it got approved. There were no shortcuts. It's just that everybody was working at the same time. And the other thing was there was basically unlimited money. And the government said, we'll pay you whatever you need to do this. So things happened quickly. Vaccine companies were willing to take risks they would never do in the free market, because if it flops, they could be out millions or billions of dollars. But this was approved so quickly at an emergency approval because it was all done at the same time. It wasn't as if they didn't do certain things that they usually do. They just started everything at the same time. Now, people always ask, why does it have emergency approval? Well, that's what you get when you first get to the point where it's considered safe. Final approval is a little different. Remember, it's government. What does that mean? Bureaucracy. I mean, pages and pages and pages of things that need to be filled out and completed in order to get final approval. I don't have any idea what that process is. I just know that it's very complex. It takes a lot of time, and there is little doubt in my mind that these vaccines all will get final approval. I think Pfizer is the closest, but you have to have all these people filling out all this stuff. And I think that it is perfectly safe the way it's been done. But I think some people may feel more comfortable just hearing, okay, well, you have final approval, not just emergency approval.
Okay, thank you. Can you please address one of the most common concerns that I've been hearing in the community, that this vaccine could potentially cause infertility, especially in females?
Sure. Yeah, you know, and that's a big deal. I'd be pretty hesitant about something if I thought that my son or daughter could not, you know, reproduce. I mean, let's face it, that is the main point we're on Earth for, you know, at least biologically. That's the main point. There was a thought, and it was a reasonable thing to consider. There was a claim that the vaccine could cause infertility by priming the immune system to attack a protein in the placenta. So if there was a protein in the placenta that looked like my friend here, then the vaccine would attack that protein in the placenta. So just to try to clarify, if there's something that looks like the vaccine, the body will have an immune response to it because it looks foreign. And we don't, many autoimmune diseases are based on that. The body attacks the wrong thing because it thinks it's foreign. It turns out that that the protein on the placenta was really not similar to what is in the vaccine, and that this was a theoretical concern. And there's no question, based on the literature that I've read, that there is no concern as to whether it's going to affect people's ability to reproduce. There's nothing that I've seen that would make me think that, because honestly, we as pediatricians would be extremely concerned if we thought we were giving something to someone that would prevent them from being able to reproduce. Now, if you get the vaccine and you have a very significant immune response, which we'll get to in a minute, might it throw off your periods for a couple of months? Maybe. I mean, we're really asking the body, we're hitting the body with something big and saying, okay, you need to protect us against this. And some people get fever and don't feel well for a couple of days. That can throw off your period, but that's nothing to do with not being able to reproduce.
So if we can roll over into that, can you talk a bit about the potential side effects from the vaccine?
Sure. There are side effects, as there are with every single vaccine. Anybody who provides vaccines knows that there are side effects with vaccines. Some of them have more common side effects, some have less common side effects. Probably one of the most classic side effects of any vaccine, just to make it real for everyone, anyone who's ever had a tetanus shot knows your arm might get sore, okay? You just know, you get a tetanus shot, and if you get to be my age, you get a Shingrix, against, what do you call it, varicella zoster, your arm might really get sore. But in terms of a more specific or more general thing, you can talk about tetanus. It is not unusual, meaning it's fairly common to get pain or redness at the site of the vaccine. You also can get some systemic signs. You can be tired, get headache, muscle aching, fever, chills, nausea. I mean, unpleasant stuff. I'm not going to kid you. This is not pleasant to feel. On the flip side, those are signs that most immunologists, people who study vaccines and people's response to them, are thrilled about, because it means you're having an immune response. Your body's going crazy and saying, okay, we got to get rid of this stuff. We have to get rid of it. And one of the consequences of revving up your immune system is things like achiness and fever. So that's not actually a bad thing in my mind and physicians' minds. I mean, you need to know that it might happen, but it's not a bad thing. There's one thing, and this is something that has been developing over time, and I try to keep up with it, but as far as I know, my information is up to date. Since maybe April or so of this year, there has been a little bit increased risk or rate of heart inflammation. And heart inflammation can be called various things depending on what part of the heart it is. You can have inflammation of the heart itself, which is called myocarditis. You can have inflammation of the covering of the heart, which is called pericarditis. This seems to only happen with the Pfizer vaccine, at least in in males, it's most common for some reason. It has not been definitively associated with it that I know, but I think it's real. And I think it's real because there's something about the spike protein, back to my friend here, and something in the heart of adolescent and young adult males that looks similar. So the vaccine, in very rare circumstances, can cause inflammation in the heart by going after those proteins in the heart. The most important thing to know about that is that there's been a warning added to the vaccine so that people know, as they should know anyhow, because anybody who had a kid would know this, if your child or significant other starts complaining of chest pain and shortness of breath, you probably ought to get medical care. I mean, that's not all that hard to figure out. The bottom line, however, is that the rate or risk of getting heart inflammation is much, much greater if you get COVID than it is if you get the vaccine. The risk of everything is much greater if you get COVID than if you get the vaccine. I mean, basically, I think I was going to say this somewhere else, but people are worried about the vaccine. I mean, it is a false assumption that the vaccine does not cause significant illness in children. it is correct that most children do well. And our practice has been very fortunate that we haven't had any very bad outcomes with patients, okay? But many, many, many children, adolescents have been hospitalized. Some of them have died. Some of them have had required lung transplants. I mean, we're not talking about small things. And if they're uncommon, you may not know anybody, but it's all a matter of, you know, you can take a, in my mind, you can take a vaccine that really has very few side effects, or you can take a chance you might get an illness that really can do some very bad things to you. At least that's the way I look at it. So.
Okay. I think the next question to address is, what is herd immunity and why is it important to get to this point so that we can see that the virus is no longer spreading?
So in a general sense, herd immunity occurs when a significant portion of a community, which is called the herd, becomes immune to a disease, making the likelihood that the disease will spread from person to person unlikely or less likely. Herd immunity is a concept with vaccines that's been around forever, and it was especially relevant back when the polio vaccine first came out. I think all of the audience, with the exception maybe of someone who's a grandparent or great-grandparent, won't remember that there were outbreaks, and I certainly don't remember because I'm not old, outbreaks in the summer of polio where, I mean, there were just thousands of people paralyzed every year, you know, from polio, and it was spread through water. So they had to close swimming pools and things like that. Once the vaccine came out, there were enough people around so that the virus didn't spread easily from one person to another. The same thing is true with COVID. There is a little bit of disagreement what level of herd immunity you need or what percentage of the population has to be covered. I mean, I've seen numbers that range between 50 and 70% of the population need to be immune to prevent spread. And I recently today read something saying with the Delta variant, which I'll get to variants in a minute, that the rate may have to be as high as 85%. And this is part of the reason it's so important to immunize adolescents and eventually children, because there are I don't know the exact percentage of the population, but if you get all the adults and then you have 30% of the population or 40% that's kids and they're not immunized, they'll just keep spreading it and eventually go back and get the adults. There's also a concept that's called community immunity, which is important, which is, you know, you could have great immunity in Danbury, or New Fairfield, say, but in Danbury, the rate's much lower. And so you have the same, it's sort of a microcosm of the bigger picture. I mean, if there aren't too many people immunized in Danbury, but there are a lot in New Fairfield, you're better off going to Starbucks in New Fairfield, if you like Starbucks. Or you go to Dunkin' Donuts if you prefer weekly coffee. Anyhow, let me just sort of jump onto this mutation thing because it's an interesting thing. Viruses change, they mutate, they change their genetic material. And if they change enough, they won't respond to the vaccine. We have a vaccine that so far, even the Delta variant, must have a spike protein that we can make an immune response to through the vaccine. To use an analogy, I try to think of something that would make sense. If you were shooting bows and arrows at a target that was 500 feet away, okay, the odds of you hitting that center and getting a bullseye are pretty slim, right? Okay, now start shooting a couple trillion arrows. Okay, one of those arrows is gonna hit there. And if that arrow, which is analogous to the virus, that changes enough that it doesn't look like this, we're in big trouble because then the vaccines won't work. That's why you don't want people spreading this, because every time the thing gets to replicate, it does something that turns out sorry, I just got a message here. The noise is from, I can't read the rest of your message. Okay, anyhow, I'll just keep talking because maybe I'm babbling too much.
Don't put your papers where they are. That's what's making the mic noise.
Oh, I'm sorry. Thank you. Thank you. Yeah.
Just figured
Yeah.
that out.
Obviously, I'm not a professional broadcaster here, nor will I ever be.
You're doing a
Um,
great job, Dr.
that-
Gropper.
that's-
Thank you.
So the point is, we don't want the virus to spread, because if it spreads and it keeps replicated, we're in trouble. I mean, we've been lucky so far that the vaccines seem to be effective. Even at this point, it's pretty clear to me that we're going to be getting boosters. To me, okay, I am not a vaccine expert. I am a general pediatrician for 32 years. Yes, I'm board certified. I do have credentials, but I'm almost sure that I'm going to be getting another COVID vaccine this winter, which will give a little better coverage against variants. In some countries, they're already giving a third one to people who are high risk, people who have lung transplants and things like that. So.
Okay. One of the final questions we have for you, Dr. Gropper, is if you have a child with pre-existing allergies, which most of us do, a lot of food allergies are out there and other allergens that are, very prevalent. Is that a contraindication to getting the vaccine?
That's a good question. When the vaccine first started to be delivered and given in England, it appeared that would be an issue. But it turns out that it wasn't the fact that people had allergies. It was the fact that people specifically were allergic to polyethylene glycol, which is in the vaccine. So people who have food allergies, which have gone through the roof over the course of my career, food allergies and other allergies, bee sting allergies or bee venom allergy, they don't need to worry. There's no specific risk related to having allergies. One of my dearest friends, who's a neighbor, has sesame allergy, and I was truly worried that he wouldn't be able to get the vaccine because of it. And within a couple of weeks, that got figured out. So allergies are not a specific contraindication, but like with everything, if you have a concern, you need to discuss it with your provider. Whoever you get your medical care from. I certainly, we have people calling me and my partners and associates all the time with specific concerns about specific things. And you realize pretty quickly in medicine that if you don't address the concern, you're really not putting people at ease. I mean, I can't tell you how many years it took me to figure out that people would come in for something that was clearly the most benign cold, and you were trying to figure out what was wrong, and all of a sudden you realize that the neighbor had a cold last month and got pneumonia and got really sick. Well, if you didn't address that this wasn't pneumonia, then you didn't address the concern. So I encourage people to, ask questions. It's your prerogative is a bad word. It's your responsibility as a parent to question things. I mean, that we all do that with our children, even our pets. I like dogs. So
much, Dr. Gropper. I think you really addressed, a lot of the main concerns that we have as parents, and having students in the district. It's so helpful to have you clarify, this information. So I really appreciate you taking the time out to do this.
Sure, you're welcome. And I hope that this has been helpful. I just want to stress that this has been a difficult time for all of us, whether we're in medicine or education or working in a grocery store. And I'm hoping that as things continue to get better, people feel comfortable getting vaccinated and go ahead and do get vaccinated. But as I said, at my job, I have never thought in practice that my job is to tell someone that, you must give your child this vaccine. I just don't work like that, and I don't think it's right. My job is to give people the best information I have at the time, and then to have the parents ask questions and decide what's most appropriate for their children. I mean, I will give someone a hard time. I think if I think the person's making a decision based on flawed information, I'll try to correct it. But ultimately, we're all responsible for our own families. And hopefully you all will stay safe and have a good school year.
Dr. Gropper, I want to thank you so much. I have to tell you, first of all, I loved your graphics. Absolutely loved your high-tech graphics.
See, that's my payment. Yeah, spending an hour and a half trying to make this circle on here. I can't tell you.
It's not easy. I also want to tell you that I really loved your analogy when you were talking about the vaccine approval process, and you explained it's like building a house and having one contractor come each day versus have everyone show up and do a build.
Okay.
Because that was something I really wondered, how did they expedite it and did they skip steps? And so I
Right.
as a parent, as an educator, as a human, feel very relieved to hear that analogy. And I love the last thing you said, that it's your job to give people information, not talk them into something.
Yeah,
And
no, not
that
at all.
that to me was really why we were with you today. We wanted to make sure that people are making decisions on the best possible information. Our goal as a school system is to get ourselves open and safe so that we can get back to the business of learning. We are not the medical professionals, which is why we're so grateful to you, Dr. Grapper, and to you, Nurse Cipriani, for taking the time to talk to our families. So I want to thank you both so much. I want to tell our families, I hope you're having a wonderful summer and getting outside and playing and laughing and having fun. And we can't wait to get back in business and see you again in the fall. So thank
Great.
you, everyone.
You're very welcome.
Here.